All right, this is the fourth and final video for today. I've logged in as a student now. So if I go over to assignments, and I'm going to click on resume here for today's assignment. And I'm going to go back to the beginning here because and I'm going to talk about all these. So I'm going to reset all this. So we'll talk about this one a little bit. Okay. I'm going to have, let's see, there. All right. So, whoops. First off, on question number one, it says, what is the U-shaped graph of a quadratic function called? And you've got a drop-down box, and it says three options: quadratic, parabola, or curve. Now, the name of the function is called a quadratic function, and the graph does make a curve, but the curve itself is called a parabola. And hopefully you wrote that in your notes. I'll do the check answer thing. It's a good habit to do, and it's correct, so I'm going to move on. Number two, when does the graph of a quadratic function open up? How about open down? So the first ones we did, they were opening up, and that was when a was bigger than 0 because it had to be positive. So you would select greater than 0. Then it opened down when a was less than 0. Okay. Now I'm going to let you do number 3 on, actually I'm going to do 3 with you, and I'll do number, actually I'm going back and forth. 3, 4, yeah, I'll let you do number 4, but I'll do number 3 since it's a little different. It's going down, so we can go ahead and take a look at that. So on this one here, they are counting by ones. So this vertex right there is one from the origin, one spot to the right and one down. So that means its coordinates are +1, -1. So I'm going to drag a 1 into the first spot and a -1 into the second. Now I can always check my answer as I go along, and it will tell me that so far I'm doing fine. Now the axis of symmetry is always x equals whatever this number was. So it was a 1. So that means it's a line that goes through the vertex, x equals 1. Now the domain, always going to be this answer. All real numbers for these things that we're doing. It's the range that will be different. So it's based on what the y is doing. This one, the y's are going down, so I know it's going to be less than. And there's only one choice here. It's this one right here. So they only gave me one option. So, and it's less than or equal to -1 because the highest y value is -1. There's no y that's higher than that. Now finally, this part might sound a little weird. So when x is less than 1, so it's talking about on this left side here, as y increases, what is x doing? So y is increasing this way. Well, I'm also moving to the right. So x has got to be increasing. So I'll put that here, and I'll do a check answer to make sure I'm doing that okay. Now the other one doesn't have to be the opposite. So on the other side here, it says as y increases, well, as y increases, I'm actually moving slightly to the left. That means that x is decreasing. So I know those last two are a little strange, but that's just how they are. So I'm going to have you do number 4 as part of your assignment. Keep in mind they're not counting by ones here, they are counting by 2s. So that'll make this a little bit different. So I want to do one more of these with you, and let's go ahead and check out this one. So as you can see, we're supposed to identify the graph of g of x equals 6x squared. And then finally it says compare that graph to the graph of f of x equals x squared. So we compare it to the parent function. All right. And I'm not sure I can make this a little wider once I've already started my recording. So way down here in the bottom corner, I've just slid my option thing down a little bit. So you do have a graphing option. So I'm going to go ahead and pull that right over here so it's in the viewer screen. Now I'm going to go ahead and graph g of x equals, there it goes, 6x squared. And I can see the graph over there. Now it might be kind of hard to see it. Now if I want to hide that, we can do this, and you can zoom in as much as you want. You know, if you want to try to see a point in here that's a little more precise. So I want to find, like, they're all at vertex 0, 0, and they all open up. So I want to find something else. So let's say it's a little hard to get exact points. One thing I could do is pull up that table. And I notice that it goes from 0 to 6. So that would be, oops, right there. There's a point right there, 1, 6. So I need to find the graph on the left side that has that. So this one here, 1, 6 would be right here. It's not quite on the graph, so it's not that one. Over here, 1, 6, that looks like it might be it right there. So I think it's this one, but I'll check the other two. 1, 6 would be to the left of the graph, and over here 1, 6 would be slightly to the right of the graph. So it definitely is that one, and you can check your answer again, and there's the green, so it is correct. Now it says I have to compare. So if you want to put in the other graph, you can. And by the way, let's say I want to reset this, click on the house, and it goes back to that. So I'm going to put in the parent function. Like so, and you can see that it's wider. So it says the graph of g is a blank by a factor of blank. Okay, so we're talking about the, I guess it's like a reddish color here. It's been moved more narrowly, so it's been stretched. So this is a vertical stretch. We have never done, I'm never going to talk to you about a horizontal stretch or shrink. So in this math class and also Algebra 2, we don't do the horizontal stretch and shrink. Okay? Very rarely will we have a reflection in the y-axis. That would be something strange, and I don't think we're ever going to do it here. You might do it in Algebra 2. But here, reflection, but that's only if it's negative out front. So this is the only option. It's a vertical stretch by a factor of, well, the number out in front was a 6. So it's this number right there. Do your check answer, and you're done. Since I have a little time, I think I might as well go ahead and do one more that's negative. So let me pick one from my list here. I'm going to go to number 12. So here's number 12, and you know, the parent graph is the same. So I'll just change this top one. So it has to go to negative 2/3. So negative 2 over 3x squared. All right, so I'm only looking at this one right now. So let's pick out some points. Now look at those. So that's not too helpful. So what I would do is I would put in some other points until I get a number that I can see. So I'm going to put in a 3, and there you go right away, negative 6. So let's find 3, negative 6. So 1, 2, 3, and then negative 6 would be right there, so it's not this graph. 1, 2, 3, and then we're counting by 2's going down, so 2, 4, 6. It looks like this one is it right here. This is interesting, by the way, because they're counting by 1's on the x-axis, but they're counting by 2's on the y-axis. That's allowed. Now, I believe that's correct, but let's just check the others to make sure. 1, 2, 3. And then 6 down would be here. It's above the graph. And then 1, 2, 3, yeah, it's nowhere near. So that is the correct answer. So this graph is wider. Let's put this function back in. So I'm going to close that. And sometimes it's easier to really compare it, put a negative out front, and you can see it is wider. You know, if I put the negative there. So it's wider, that means it is a vertical shrink. Okay? By a factor of, well, it's the number in front. So 2/3. Let me move this out of the way a little bit. So it's by a factor of 2/3. It's not negative 2/3 because the negative flipped it down. The 2/3 is the thing that made it a vertical shrink. Now the negative, I just said flipped it down, but we don't call it a flip down. We call it a reflection in the x-axis. I'll check all my answers, and you can see they're all correct. So that's my second video. Actually, what am I saying? It's my fourth video. So hopefully these were helpful.